Hello everyone, welcome back. Good day to all of you. We have seen the limitations in CSL testing. One of them is in evaluating the quality of concrete only within the reinforcement and not outside the reinforcement. How are we going to overcome this limitation? We can overcome this limitation by performing a thermal integrity profile testing or TIP testing. Hi, I am Parthasarathy, founder and managing director of Sarathy Geotech and Engineering Services Private Limited. We are technical partners of Pile Dynamics Inc. USA and represent them in this part of the world to conduct training programs and provide tech support. This thermal integrity profile is an advanced method of evaluating the quality of concrete in a drill shaft. This utilizes the thermal wires which has thermal sensors, and it is run along the reinforcement cage. These thermal sensors has been developed over the years, and today we have a very rugged thermal sensors which has a data loss at 45 kg. It has a soldered connection, heavier gauge cable and injection molded shell. So these thermal wires are embedded into the reinforcement cage. But how many wires are required? As a thumb rule, for every 300 mm diameter of pile, one wire is required. For example, for a 1.2 meter diameter, 4 thermal wires is required, that is embedded along the reinforcement cage to the bottom of the pile. And then this reinforcement cage is inserted into the pile borehole and the concrete is poured. During curing of cement, the heat is generated. The thermal integrity profiler utilizes the heat generated during the curing process and evaluate the quality of concrete in the drill shaft for auger cast piles, for board piles, for secant piles, for CFA piles, for diaphragm walls, etc. Cooler temperature depicts there is an anomaly or defect. Warmer temperature depicts there is an overpour or a bulge. So these thermal wires are connected to TAP, thermal acquisition port units. These thermal acquisition port units or TAP units samples the data in those sensors on that wire for a user defined period or time intervals. Usually it's about 15 minutes, and the data is saved in the TAP unit and people can download this data at a convenient time. The data could also be viewed in real time using a TAP thermal aggregator port or a TAG unit via the cloud. So the thermal integrity test is performed as the curing process is happening, and therefore there is not much delay in the construction schedule. This will evaluate the integrity not only within the reinforcement but also outside the reinforcement. Thermal integrity profiler will also provide you an idea of the alignment of the cage along the length of the shaft. The thermal integrity profiler is gaining momentum in the West. I am sure in this geography too, the momentum will be gained in the coming days. Just a comparison between the CSL testing and thermal integrity profiler. For CSL testing, you need to have the access tube, you need to have the testing engineer on site, the interpretation to be performed in the office, then post testing you have to grout the tubes. For the thermal integrity profiler, you need the thermal wires with thermal sensors as a consumable, you have to do the interpretation. And the cost comparison, the overall cost of the integrity for these two methods, thermal integrity profiler is about 40% cheaper than the CSL test methods. I hope this information was useful. None of the integrity methods will give you any indication on the bearing capacity of the pile. In order to assess the bearing capacity of the pile, you have to perform a high strength dynamic test, and I will bring out the methods of conducting high strength dynamic test in my next video. Stay tuned for more information. Until then, happy learning, and I'll see you in my next video. Thank you.